Okie dokie. We're going to go ahead and talk about acid rain. So, acid rain is sometimes called acid deposition, and there's a reason for that. It's depositing acidic compounds, which can be dry or in the form of precipitation. So, you can actually technically have acid rain, acid snow, acid mist, or acid fall. So, dry acid deposition, which is just the chemicals being deposited on surfaces, is about a half of all of the acidic compounds that are deposited from the atmosphere. So, these particles and gases can blow on to various structures and cause the same effects as acid precipitation does. So, just a reminder for those of you who've had chemistry, pH is how we measure how acidic or basic something is. If it has a pH of 7, that is neutral. Pure water has a pH of 7. Anything that is a pH less than 7 is going to be acidic. Anything with a pH above 7 is going to be basic or alkaline. So if you look here, the pH of distilled water is 7. The pH of clean rain that is not considered acidic rain is going to be 5.6. So normal rain is slightly on the acidic side. And then if you look, acid rain has an even lower pH of about 4.3. And 4.3 is not acidic enough that if you go outside, it's going to feel like it's burning you, but it is acidic enough to cause some chemical reactions and do some damage, especially over long term. So, what causes acid rain? It's primarily nitrogen oxides and sulfur oxides, so NOx's and SO2s. These can be released from natural sources or from anthropogenic sources and be released by humans. There's some of the air pollutants that we've already talked about. Acid rain is a secondary pollutant, and that means that it is not directly released from a source of pollution. So it's not like acidic compounds are just shoved into the air. Instead, they're the result of these secondary chemical reactions. So the NOx's tend to come from motor vehicles as well as some coal fired power plants. And the SO2, sulfur dioxide, comes from coal fired power plants mostly. Here, in case you were interested, is the set of chemical reactions that form acid rain. So, sulfur dioxide will react with oxygen, and in the end, it will make sulfuric acid. It also has some reactions with water vapor in the air as well. Nitrogen dioxide will react with water vapor in the air, and that forms nitric acid. So, both of these acids can then become a part of acid deposition. So, what are some of the effects of it? Well, most acid deposition is going to happen kind of downwind from coal burning power plants. So, all of these chemicals are released from these power plants, and then wind is going to drive them in whatever direction the prevailing wind blows. Those will react with oxygen and water in the atmosphere, and that will make these acidic compounds like nitric acid and sulfuric acid that then rain down onto communities. So, places that are near a coal burning power plant are going to be more likely to have a higher incidence of acid deposition. So, what are some of the environmental effects? Well, it tends to acidify soil as well as bodies of water. Problem with that is that all organisms have a these ranges of tolerance, which are the environmental conditions that they can grow best in. If you change the environmental condition, then that can make organisms sicker and make them less likely to survive, make them more susceptible to disease, and eventually kill them if it's significant enough. So, acid deposition, for example, when you have acid deposition in forests, what that contributes to is nutrients being leached from the area. So, then you're going to have calcium, magnesium, etc., being released, being carried away by runoff. That's what leaching is. Something gets dissolved in water and it gets carried away. You'll have extra aluminum taken up by the trees, and that also uh, leads to some health effects for the trees. So they have less cold tolerance, and that means that they're going to be damaged by freezing temperatures more than they otherwise would. Um, Another thing that these acidic chemicals, these acids, when they make bodies of water more acidic, that can react with metals that are in the water or in the whatever the lake bed or ocean bed or river bed, and that can release harmful metal ions that can have negative impacts on organisms in the area. But there are some differences in the impacts of acid deposition, and that depends on what type of soil and what type of rock is there. For example, if you have limestone making up the bedrock of the area, like if you go outside actually and you dig in most yards here in Oak Cliff, you'll actually hit limestone. For example, I've dug in my backyard about 6 inches deep, hit a layer of limestone. Well, limestone can actually be beneficial because limestone contains compounds that can neutralize those acids. And so, if there is limestone in the soil or in the rock or the sediment under a body of water, then that can neutralize some of the acid and then mitigate or decrease some of those impacts. You could also potentially use crushed limestone to add to soil to try and decrease the acidity. Another environmental impact to plants, especially, remember, plants aren't mobile. They can't move out of the way, so they're just subjected to whatever acid deposition occurs around them. And that can actually damage the cuticles or the waxy covering of plants. And the waxy covering of plants is important not only to prevent water loss, but it also kind of serves a bit of an immune function in that it prevents pathogens, disease causing organisms from getting into the plant. Another impact of acid deposition is that it can help damage or destroy buildings, things that you put on the exterior of a building, like paints, statues, sculptures, even some graveyards and cemeteries. A lot of the gravestones have been eroded by years or decades of acid rain, which make them less readable. This example is from the country my parents are from, the Taj Mahal, which is one of supposed to be one of the seven wonders of the world. This was how it originally looked. It was a very beautiful, like shining white building, and now it's become yellowed. And that is in part due to acid deposition, which is damaging the marble that makes up the Taj Mahal. And so there's worry that someday the damage can be severe enough that it could, cause the Taj Mahal to um, maybe like collapse, or at least, it's a major tourist attraction for India. Um, it's, like I said, one of the seven wonders of the world. So, the damage that would be done to it would be it's an irreplaceable building, and it would be difficult and expensive to fix. And then if there continues to be acid deposition in the area, you could fix the damage, but then more damage would occur after that. So, how can we reduce acid rain? Well, one thing is make sure that there's lower nitrogen oxide emissions. So, that would be having more efficient automobile engines or reducing gasoline usage, reducing automobile usage, all those strategies that we've talked about with how you reduce air pollution. You can add technologies to power plants and industrial smokestacks and things like that that can help remove sulfur dioxide and NOx's from the exhaust that's put into the air. So those are things like scrubbers or filtration or catalytic converters or catalytic burners. Those will help you reduce the amount of these chemicals that are being emitted. You can also set regulations. So you can, as a governmental agency, set penalties for not reducing emissions, give tax incentives for reducing emissions, incentives to buy Energy Star appliances. These are more energy efficient, and therefore they'll reduce the amount of electricity used. Decreasing the amount of electricity used means burning less coal. And so that can lead to a reduction in the amount of sulfur dioxide, especially, that's being released. And then you can increase cafe standards. When we talked about reducing air pollution, I brought up the corporate average fuel economy standards, which is how many miles per gallon a vehicle needs to get. If you make vehicles more efficient and increase the cafe standards, that means they need to be able to drive more miles for every gallon of gas that's burned, which can decrease the amount of gas that's burned, and that will decrease some of these air pollutants that can lead to acid deposition. So, in the, I think, 1990 revision of the Clean Air Act, one of the things that was set up was the Environmental Protection Agency ended up having this program set up to reduce acid rain. So the red is indicating kind of the concentration or the incidence of acid rain, and this diagram is showing you 1985. Well, this diagram is showing you 2014. So notice, in the Northeast, there's a lot of coal-fired plants because coal was mined in that area, so there's not a lot of distance to transport it. Here in Texas, we might burn more like oil or natural gas, just because that's a local fuel source. You don't have to pay to ship coal to us. We'll notice there was a dramatic decrease in the incidence of acid rain in the Northeast, which could be considered a success of that program. So that is it for acid rain. Only one more lesson till we're done with Unit 7.